This video covers Logit and Probit models. The data set we're going to use comes from Virginia Page Fortnow's Peacekeeping and Civil Wars data. As in previous videos, we're going to look at the relationship between conflict recurrence and several other independent variables, including truces. So conflict recurrence, short-lived 365, is a dummy variable which takes on a value of 1 if the civil conflict recurred before the end of the calendar year. Truce is also a dummy variable which takes on a value of 1 if the Civil War ended in a truce and 0 otherwise. Victory is government victory, and it takes on a value of 1 if the government won the Civil War and 0 otherwise. And life expectancy, or life E, is the life expectancy of the population in which the Civil War occurred, and it's measured in years. So we're going to begin by looking at some descriptive statistics of these variables. So first we can see that the range in life expectancies is rather large and ranges from around 31 years to about 76 years, with a mean of about 55 years. Government victory, so all in out government victory, is rather rare. Occurs less than 20% of all Civil War outcomes. Truces occur slightly higher in about 32% of all Civil War outcomes. And then conflict recurrence is rather rare, so about 18% of all civil wars experience a recurrence within the first calendar year. So our dependent variable is binary. We're going to begin by running a linear probability model. So the coefficients are probabilities. We can see right off the bat that each of these variables is statistically significant at over a 95% confidence level. So the Civil War ending in a truce increases the probability of conflict recurrence by about 35%, holding government victory and life expectancy constant. Government victory decreases the probability of conflict recurrence within 1 calendar year, holding truce and life expectancy constant by about 17.1%. And then life expectancy, so an increase in the life expectancy by 1 year, holding truce and government victory constant, decreases the probability of conflict recurrence within 1 calendar year by about 0.7%. So our R-squared is approximately 0.21, and this tells us that our model explains about 21% of the variance in conflict recurrence. So one of the main shortcomings of linear probability models is that sometimes we can get fitted probabilities that are less than 0 or greater than 1. So we're going to check to see if that's the case. So yes, there are values that are less than 0, there are none that are greater than 1, but negative probabilities are nonsensical. So what we can do is there are a couple of different options. So there are multiple nonlinear functions whereby we can fix the probabilities between 0 and 1. So two examples are Logit and Probit. And so these models are fairly similar in the sense that the standard normal CDF for the Probit is very similar in shape to the logistic CDF. So both of these are increasing functions. And they both imply diminishing magnitudes of partial effects. So at the tail, it tails off, so there's diminishing increases over higher values. And so each of these increase most quickly at around 0. So typically it's a matter of preference whether you choose Probit or Logit. In general, or at least in the past, economists have primarily used Probit models, while in some fields in political science, Logit models are used more frequently. So first we're going to begin by looking at a Logit model. So these coefficients are actually the log odds. And a couple of things we can notice. Truth and life expectancy, once again, are statistically significant at over a 95% confidence level. So the way to interpret these coefficients is to begin by looking at their sign. So truth is positive. This coefficient tells us that the Civil War ending in truce, holding government victory and life expectancy constant, increases the log odds of conflict recurrence by about 2. A 1 unit increase in life expectancy, or increasing life expectancy by 1 year, holding truce and government victory constant, decreases the log odds of conflict recurrence by about 0.06. And then government victory has been dropped. It's been omitted, actually, due to perfect prediction. So this is not an uncommon result in Logit and Probit models. So in the case of complete separation, you need to make sure that the outcome variable is not some sort of dichotomous version of this government victory variable, or whatever variable that's being omitted due to perfect prediction. So this is not the case in this model. So it's telling us that there's some other type of separation. So what we can do is we can run a crosstab of our independent variable and our dependent, of our dependent variable and our independent variable. And we can see that there is perfect prediction in the sense that when the Civil War outcome ends in a government victory, there is never a conflict recurrence within 1 calendar year. So this variable is actually sorting the outcomes of our dependent variable perfectly into these 2 categories. So one simple strategy to deal with this is just to exclude government victory from these models. The problem is that if you think that government victory likely affects conflict recurrence and is correlated with our error, you're going to have a problem with omitted variable bias if you exclude government victory from these models. It's possible that if your independent variable is not binary, you may be able to collapse some categories of the independent variable in order to deal with this perfect separation. However, you should only do this if it makes substantive sense. And in this case, our variable is already as collapsed as it can be. It's a binary variable, so there's nothing we can do about it in that sense. So the best approach is actually to leave it in if you think that omitting it would cause bias in the estimates of the other coefficients. And particularly in some ways, as we see that it is perfectly separating our dependent variable, it makes sense that government victory and truces are probably correlated. We ought to leave this variable in the model. So if we want to look at odds ratios instead of log odds, what we can do is we can exponentiate the coefficients. So first we're going to exponentiate them manually so you can see what's going on. And we're going to run tab. So this is the odds ratio instead of the log odds. And we can do this instead of doing each variable manually. We can run two different types of code. We'll produce equivalent results. The first is to add comma space OR to our Logit model we ran here. So that's what this line of code is. Also, what we could do is change Logit to logistic, and so these would be equivalent. So I'm going to run both of these models, and you can see that they're both producing the odds ratios. Otherwise, they're equivalent, or they are equivalent. And again, this is the same value as our calculated odds ratio when we exponentiated the log odds manually. So the way to interpret odds ratios is that the value of 1 tells you that the variable does not affect the outcome variable. And having an odds ratio greater than 1 tells us that the independent variable increases the odds of your dependent variable. Having a value less than 1 tells you that your independent variable decreases the odds of your dependent variable. So we can see with this odds ratio that truth increases the odds of conflict recurrence within 1 year, holding government victory and life expectancy constant by about 7.8. And so life expectancy, once again, decreases the probability of conflict recurrence. So increasing life expectancy by a set amount decreases the odds, and this is our odds ratio for life expectancy, holding truth and government victory constant. Once again, because we are running a Logit model, which implies these diminishing magnitudes of partial effects, change in life expectancy from 34 to 35 years will not have the same marginal effect on the probability of conflict recurrence that it would a change from 52 to 53 years. So next what we can do is we can actually compute predicted probabilities. There are a couple of other differences I'd like to examine with respect to these models. So first is the Rsquared. So these models produce a pseudo R-squared as a default, and pseudo R-squareds, you need to be more cautious when comparing these across models than you do in a typical OLS regression. So OLS R-squared ranges always from 0 to 1, which makes sense because it's a proportion and because it's also the squared correlation. So sometimes pseudo R-squareds do not actually range from 0 to 1. They only superficially match the scale of the OLS R-squared. And so this creates problems when comparing across models. So it's important that your dependent variable is always the same if you're going to compare some sort of pseudo R-squared value, because the scales are not going to be similar across models. And then second, in terms of the intention of the R-squared, so in the OLS context, Remember that OLS minimizes the squared differences between the predictions and the actual values of the predicted variable. So this is not true for logistic regression and also for Probit models. So the way in which R-squared is calculated in OLS captures how well the model is doing in terms of what it aims to do then. But in logistic and Probit models, since the goal is not to minimize the squared differences between the predictions and the actual values of the predicted variables, the pseudo R-squared is not telling us the same information. So when comparing two logistic models, predicting different outcomes, the intention of the models might not be captured by a single pseudo R-squared. So what we can do, if you'd like, is to install this fit stat, and it's going to produce several different measures of fit. I'm not going to go through each one of these, but it's good to know that you're able to calculate them if you would like, and depending on your model, different measures of fit are useful. So next we're going to look at computing predicted probabilities. So this will be covered much more extensively in MLE, particularly in terms of setting your variables to their observed values instead of their mean values or some other set of values. But in this case we're going to look at margins, and we're going to start by setting our independent variables to their mean values. So what is this telling us? So in our actual equation, what we're doing is we're setting the value of truth to be equal to its mean, and then government victory, it is perfect prediction, so in this case it's going to be 0, and then life expectancy, again we're setting it equal to the mean. And this is giving us our predicted probability at each, considering these values. So when truth and government victory and life expectancy are set to their means, the predicted probability of conflict recurrence is about 24%. So next we're going to look at the Probit model. So you can run Probit in Stata by specifying Probit, and then your dependent variable, and then your independent variables. Once again, you can use margins to calculate predicted probabilities. So in this case, again, we're just setting everything equal to its mean, and this is telling us the predicted probability of conflict recurrence. So you can see that the result is very similar to what it was when we used the logistic model. It's about slightly higher for the Probit model, but it's very similar. So another way of looking at the marginal effects is you can run something called dProbit. I think this is maybe less commonly used now that margins exist. But so what dProbit tells you, it reports the marginal effect. So for continuous variables, it reports the change in the probability of your outcome variable, which in this case is conflict recurrence, for a very, very, very small change in the independent variable life expectancy. And by default, since truth is a binary variable, it's going to report the discrete change in the probability of conflict recurrence. So again, what we're seeing is very similar results in the sense that truth increases the probability of conflict recurrence, and life expectancy decreases the predicted probability of conflict recurrence. You could also run the margins command by setting these values to something maybe a little bit more sensical. Since truth and government victory are binary variables, it makes maybe more sense to set them equal to one of these values that you would observe in life, such as the Civil War ended in a truce, which is a value of 1. Conversely, you could set it equal to 0 if you wanted to look at some other outcome. So here we've set truce equal to 1, and then we're looking at the probability of conflict recurrence within 1 calendar year. And you can see that when we do this, it increases the predicted probability of conflict recurrence to about 52%. So this makes sense since the coefficients on truce for all of our equations thus far has been positive. So it's telling us that truce increases the likelihood of conflict recurrence within 1 calendar year.